My name is Dr. Rajeev Kumar Chauhan. I am a senior member of IEEE. I have done PhD from IIT Mandi, and currently I am working as a assistant professor with the Department of Electrical Engineering at Galgotia College of Engineering and Technology, Greater Noida. I am a former research scientist with the University of Manchester, United Kingdom. Today I am going to discuss about digital logic design, and in this topic, in my previous lectures I have discussed few basic theorems and properties to solve the Boolean, which are required to solve the Boolean algebra, okay, or Boolean theorems. So, I am continuing the next expression, how, what are the physical significance and how they are used in the circuits, okay, and what are their different specifications. Okay. So, Boolean expression for Boolean expression, if we have the a dot a bar, what does it mean? So, dot represent the series circuit, while a, if I am saying a bar, so a, whatever the value of a, the a bar is opposite of that one. Like if I am saying a is in high state, then a bar represent low state, okay. Means either switch, if switch a is on, so switch a bar, if I am saying the another switch is in series with a, and that is represented by a bar. So, the state of the switch a bar will be, if the state of a is high, then the state of the a bar switch will be low, okay. So, a in series as per the dot product, or not a means open switch, okay. So, here we can see the switch, there are two switch are connected in series, a and a bar, okay. So, a and a bar means, but both are connected in series. So, for example, in similar to the previous one, this is plus minus, and I am saying one appliance is connected here, okay. This is connected here. So, if this switch is, if I am saying a is equals to 0, a is equals to 0. So, 0 represent the off state and this is off. It means, if a is equals to 0, then there is no, this switch is closed, still here till here, this switch is closed, okay. But there is no path because of a, switch a is open. It means the appliance is not connected to the source. It means there is no current in the path. It means the appliance will remain in off state, okay. If I am saying that a is equals to 0, a is equals to 1, okay. So, if a is equals to 1, okay, then it will become open, it will become open. Is it clear? So, if it is closed, but this will become open. So, because this is open, it means no current will flow, still no current will flow to supply the appliance, okay. So, output remain 0 in both the cases if two switches, one is a and second one is a bar, are connected in parallel, or two switches, one is a and second one is not of a, are connected in series. The output will be always 0, either the value of a is 1 or 0, okay. Now, next case is a plus b is equals to b plus a, okay. So, what does it mean? In both the side we can see there is a positive sign. It means there are two switches, a and switch a, one is a and switch 2 is b. Two switches are connected in parallel because of plus sign, okay. So, from here we can see we have used two switches which are connected in parallel. One is switch A and second one is switch B. Okay. This is appliance. Okay, load. Now, does it affect if I will say this is, if we will reverse it, just rotate the switch. So, what will become? If we will rotate it, it will become like this. This is B, this is A. Still both are connected in parallel. Okay. So, let us check the statement, like if I am saying A is equals to high, means A is closed while the B is open. Okay. So, what will happen? So, if A is closed, it means the current will go from here and it will remain on. Okay. So, B A is equals to 1 plus B is equals to 0 is equals to 0 plus 1. So, output is 1. Okay. Now, A is closed, B is also closed. So, both are high. 1 plus 1 is equals 1 plus 1 and then output is still remain same. So, it does not affect if both the switches are connected in parallel, it does not matter which one is the first one and which one is the second one, and both are connected in parallel, their state will affect the output. Okay. And it we called it commutative rule. Okay. Now, second one is the A dot B and B dot A. It means both the switches are connected in, because of dot can say both the switches switch A and B are connected in series. Okay. Or we can say B and B in series with A. So, there are two switches A and B, because of dot product both are connected in series. Okay. So, whenever one will be open, the output will be 0. Okay. So, it does not matter either you are connecting the switch A first to the circuit or B. Okay. If both are connected in series, it does not affect. Okay. So, either you can write down A dot B or B dot A, the output will remain the same in both the cases. Okay. Now, third one is the A plus B whole bar, okay, is equals to A bar dot B bar. Okay. Invert and replace with OR and AND. Okay. So, what does it mean? So, we have like two switches A and B, and there is a whole bar. What does it mean? It means that if A and B, both the switches are connected in parallel, because of this is a positive sign. Okay. So, we can take it, this is switch 1 and I am saying this is switch B. Okay. So, A plus B and then whole bar represent whatever the output is coming from these two switches, we have add one another NOT gate. Okay. So, we have like keep one switch on, like B is equals to, if I am saying B is equals to 0 and A is equals to 1 for example. So, B is equals to 0 means B is equals to 0 means this is open, this is closed. Okay. One is closed and second one is open, but both are connected in parallel, it means the output will be 1. But so, we get the output 1 here, and when this 1 will go to pass through the NOT gate. So, what will be the output? Actual output of the circuit, the output will be 0. Okay. And from here we can see if two switches are connected in series. This is the case, okay, and the output of each switch is going to the NOT gate. So we have feed 1, like this switch is closed now, so the output will be 0, okay. Now the next switch is also closed, the output is 0. The output of this switch is still 0. So we get the output 0 in both the cases. Either you connect the two switches in parallel, but the output of the two switches which are connected in parallel is passed through the NOT gate, the output is remains 0. If you have two switches and their output is are connected in series, and each gate is passed through the output of each switch is passed through the NOT gate, the output remains same, means 0. So we can say that a plus b whole bar is equals to a bar dot b bar, okay. Now next one is the if a dot b bar is equals to a bar plus b bar, okay, invert and replace with the OR gate. So we called these two theorems is De Morgan, both the statement for the De Morgan theorem, either a plus b whole bar is equals to a bar plus b bar, a bar dot b bar, and if a dot b whole bar then is equals to, so what does it mean? So if you have the OR gates and whole bar, then you output you will get the both the gates are with are connected with NOT gate, okay. So these are the rules for the basic rules, a plus b is equals to b plus a, which I have discussed in previous slides till now, okay. So the basic theorems and their properties, like I have discussed the different rules, and let's verify them, either they are, why I have said I have shown the physical significance, but if you have the Boolean expressions, how you will use these rules and how they are correct, okay. So just prove them, okay. So this is rule number 1, I am using a plus a is equals to a, okay. So this is left hand side, this is LHS left hand side for this statement, okay. So a plus a is equals to, we can write down a plus a, and if you will multiplied with the 1, means a, if you connect two switches in series and one switch is a and second one is the switch which has their state in closed mode, means in switch on mode. So in switch on mode, so it does not affect the output will be depends on the first switch, okay, and that is 1 plus a dot 1 is just series connection, okay. So you can write down like this. This is the another one, a plus 1, a plus a, and we know that if we can also write down 1 is equals to a plus a bar. Let us check. If I am saying a plus a bar, so for example, if a is equals to 0, so what will be the value of a plus a bar? Is equals to 0 plus 0 bar is equals to 0 plus 1 is equals to 1, okay. Now if a is equals to 1, so a is equals to 1 means this is 1 plus 1 bar is equals to 1 plus 0 is still output is 1. So we can write down it like this, 1 can be written as 1 a plus a bar, okay. Now there are two brackets, both there are two combinations, a plus a bar dot a plus a bar, and from this we know a plus b dot a plus c is equals to, we can write down a plus b dot c. This is distributed law, okay. So this is distributed law. So, we have just use these two brackets. So, in both the cases A is here. So, I write down A, and second is A, and this one is A bar. So, A dot A bar. Okay. And from here we can find out A plus A bar, sorry, A dot A bar is equals to what? So, let us assume is equals to 0 or not. If this equals to 0, let us verify if A is equals to 0. Okay. So, A dot A bar will be 0 dot 0 bar or 0 dot 1, and if you will use the 0 dot 1 is equals to what? 0. Okay. Now, A dot A bar in case of A is equals to 1. If A is equals to 1, then A dot A bar is equals to 1 dot 1 bar equals to 1 dot 0. The output is still 0. So, we can say A dot A bar is equals to 0. So, that is why I write down this one as a 0. Okay. So, A plus 0, we know that A plus 0 is equals to A. Okay. So, it has been proved that A plus A is equals to A. Okay. Now, this is another theorem or another basic property. This A dot A is equals to A. As we know, if A is equals to 0, A is equals to 0. So, 0 dot 0 is equals to 0 from left hand side, from this, from A dot A. Okay. If A is equals to 1, if A is equals to 1, so 1 dot 1 is equals to 1. What does it mean? It means dot means both the switch are connected in series. So, it will be like this. Okay. This is A, this is another A. Both are connected in series, and if both the switch are closed, from here I am saying 1, A is equals to 1, to 1. It means we will get the connection. Okay, we will get the output. Means if we have the source to supply some load, it will glow. Okay, so the output will be 1. Okay, if any one of the switches, off, if this switch is off, it means there is no path to supply the current. There is no path here, the open circuit. So, no current will flow, it will remain off or 0 stat. Okay. Now, left hand side. So, A dot A is equals to, we can write down it like this, A dot A plus 0. Okay. A dot A plus 0 means these two switches are there, and if I am saying there is one another switch which always remain open. So, does it affect? No, it will not affect the current, because if the output is depends on these two switches only. Okay, because this one is considered as off switch, it will remain always off. So, it does not affect the output. Okay. So, that is why A dot A plus 0 we can write down. Okay, no problem. And 0 is also written, we can also write the 0 is if we connect the two switches which are not to each other in series. Okay. So, A dot A is equals to 0, as I have discussed in the previous lecture. So, A dot A is equals to 0. So, I have write down A 0 as A dot A bar. Okay. Now, we know the formula, this one is equals to. So, what we can do? We can write down it A dot first one plus second one. Okay. So, A dot A plus A bar, clear. Then A plus A bar, we know if two switches are connected in parallel, if two switches are connected in parallel, I have discussed in my previous lecture in detail. Sorry, and this is the appliance and this is one plus minus. Okay. So, if one switch is from here, if one switch is on, one of this is A, this is A bar. Okay. If one switch will be on, then circuit will complete. Okay. So, we can say A plus A bar is equals to how much? Is equals to 1. Okay. So, whatever the value of A, the output will always remain 1 when two switches are connected in parallel with opposite, or we can say with the NOT gate. Okay. So, if one switch is high, second one is low, and if the second one is high, first one is low, but both the switches are connected in parallel. So, we will get the load will connect with the source. So, it means we can write down it like A dot 1, and we know A dot 1 is equals to A, because what does it mean? It means one switch A, we have one switch A and this is another switch, and there is plus minus. Okay. And this is our appliance. This switch always remain it closed because of 1. Okay. Always closed. So, the output is depends on totally on this switch. This is A. Okay. And dot product tell us that both the switches are connected in series. Okay. So, we can say it has been proved that A dot A is equals to A bar, sorry, A dot A is equals to A. Okay. Now, example number 3 or theorem 3, here A plus 1 is equals to 1. Okay. We know if A is equals to 0. So, what will be the output from here, from this equation, like A plus 1. This is our left hand side, this is the left hand side, and we want to check and what will be the value of left hand side if we have A is equals to 0. So, if A is equals to 0 means 0 plus 1, 0 plus, because in here we have A plus 1. So, 1 will remain always 1. Okay. And A is the state of the switch. Okay. So, if A is equals to 0, so 0 plus 1 is equals to 1, we know, because these, it means both there are two switches which are connected in parallel because of plus sign. Okay. But the state of one switch is remain always in the on state or in closed mode, that is represented by this one. Okay. So, it means the output will remain always high. Okay. So, 1 plus 0 plus 1 is equals to 1, it means high. Now, next one is if A is equals to 1. So, if A is equals to 1, it means 1 plus 1 means two switches are connected in series and both are closed. So, if both the switches are closed, it means the output will be high. From here you can see plus minus. Okay. So, this is one switch, if this switch is also closed, this switch is also closed, we will get the current get the path to supply the load. Okay. So, that is why 1 plus 1 will be 1. Okay. Now, take the left hand side, A plus 1 is equals to A plus is equals to 1, we want to prove it. Okay. So, let us take left hand side, a plus 1 is equals to, we can write down a plus 1 dot 1. It means one another switch is connected. There are two switches which are connected in parallel, okay, which are connected in parallel, and one another switch is connected which remains in the high state, but this switch is in series with these two switches. Okay. So, a plus 1 dot this one, okay, and this one can be written as a plus a bar, because we know that two switches are connected in parallel, but their state always remain opposite. Like if one switch remain high, second will remain low, or one switch will if one switch in on state or closed, the second switch will be off or open, okay, but they are connected in parallel. So, you will get the output high, because one switch will supply to the load when the other will be off. When the second will be off, first will supply. When the first will be off, the current will go through the second one. Okay. So, that is why the a plus a bar is equals to 1. Is it clear? Okay. Now, second case is, so what we have done? We have just write down a plus 1 is equals to this dot a plus a bar, okay, from here. Okay. Now, from this we know that a plus b dot a plus c, this is from here, a plus b and second one is a plus c. So, we can write down it like this, a plus b dot c. So, we have just reduced this equation like this one, a first one, a plus 1 and second one, okay, 1 dot a bar. 1 dot a bar means the output will be always how much? A 1 dot a bar. So, if the value of a is equals to 1 dot a bar, means the state of the switch is depends on the a bar, because both the switches are, dot means both the switches are connected in series. Okay. Both the switch are connected in series, and one is always remain closed, but second one is the a bar. Okay. So, if a is equals to 1, then it will remain closed, the output we will get some output. If a is equals to 0, sorry, this is a bar. So, if a is equals to 1, it will closed. If a is equals to 0, it will remain open. Okay. So, this is, that is why we can say a plus a bar. Okay. If two switches are a and a bar, but both the switches has different opposite state, one, if one is high, second one is low, and second one is high, first one is low, or if first one is closed, second one is open, and if second one is closed, first one is open, but both the switches are connected in parallel like this one. Okay. This case, if both remain, so the supply will be always, we will get the output 1. So, that is why we can say a plus 1 is equals to 1, because we get always output 1 from this equation, if this is the statement. Okay. So, this is the right hand side which is mentioned in the question paper, and it has been proved that a plus 1 is equals to 1. Okay. So, I hope this one is clear to all. So, If you have any query, you can write down an email to me at rajevnitj@gmail.com. I will be happy to help you to understand the concept of different theorems, Boolean theorems. Thank you very much.